Okay, Vaughnables, I'm back for question number 2. And if you look at question 2, this looks kind of nasty. You've got a bunch of fractions, and it just looks like a total mess. But I'm going to get you through this one. It'll be okay. We're going to do this exactly the same way as we did the other one. We're going to first find that vertex point. And if you recall in the previous problem, the vertex point is at the minimum or the maximum point. So I'm going to set that green part equal to 0 and solve for x. So I'm going to have negative 2/3 x minus 4 equals 0, because that's either going to be the minimum or the maximum point. And in a second, I'll explain which one it actually is, although you might be able to tell which one it's going to be just by looking at the coefficient out in front there and the sign of that coefficient. And you'll be able to tell whether the v is going to go up or it's going to go down. So I go back to my equation and I solve for x. I get negative 2/3 x, add 4 to both sides, equals 4. Multiply both sides by negative 3/2. And that's going to give me x equals negative 12/2, or x equals negative 6. So my vertex point of my graph is going to be at negative 6, comma. All right, now if you recall from the last one, that negative 3 out front is not the y-intercept. That's actually the y value on our vertex. So I know my vertex point is going to be at negative 6, negative 3. And just to review, you remember, because at that particular point, when x is negative 6, everything inside the absolute value goes away, and you're left with y equals 1/2 times nothing, which is nothing, minus 3. So y is equal to negative 3 when x is negative 6. So I've got my vertex, and I'll plot it right now. So negative 1, 2, 3, 4, 5, 6, down 3. There's my vertex at negative 6, negative 3. My axis of symmetry, I'm going to put my dotted line in to show my axis of symmetry. So everything is going to be symmetrical for my v graph over that particular line. And that was x equals negative 6. So my equation for the axis of symmetry is x equals negative 6. You recall that every vertical line, all the x values stay the same. So there's no y in a vertical line. It's just x equals negative 6. And you might also recall that that is x equals negative 6, or x equals problems are the only linear equations that are not functions. All right, so let's go back through and let's actually draw this. Remember how I did the thing with the slopes before? And you got to be very careful here, because there's a 1/2 out in front and there's a negative 2/3 inside. And to actually find the true slope, you're going to have to multiply those two together. So the slope that I'm going to be using here, m, is going to be 1/2 times 2/3. Now you'd probably be saying, well, what happens about that negative? Well, you don't have to worry about that negative. And by the way, that equals 1/3. Because with the absolute value, it's going to be positive anyway. So don't even worry about that at that particular case. The only time you worry about the negative is if it's out in front of the absolute value. Since there's no negative out in front of the absolute value, that tells me that my graph, my v, is going to go up instead of down. And the slope that I'm going to use is going to be 1/3. So if I start at my vertex point, I'm going to go up 1 to the right 3. There's a point. Up 1 to the right 3. There's another point. Hey, look at that. I got my y-intercept. I'll put that down there for now. I mean, I'll go back and calculate it later, but I'll just write it down so you know you have it. And then I'm going to go up 1 to the right 3. Hey, there's one of my x-intercepts. So I'm going to have an x-intercept of 3, 0. And that should be enough for me to actually draw my line. So I'm going to actually put that in right now and start at the vertex. I go too far. It's going to go that way. And it's also going to go the other direction because it's going to be symmetrical over that axis of symmetry. So if I go up 1 to the left 3, up 1, oh, it's off the graph already, somewhere over here. So that's another reason why you have to be able to calculate algebraically your x and y intercepts. So in this case, let me draw in the lines and see what it's actually going to look like. It's going to be off here to the left. But let's go ahead and calculate that x-intercept so you can get practice actually working your absolute value anyway. So if I come back to the original problem, y equals all that stuff up top, you recall that at an x-intercept, the value of y is 0. So if I rewrite the equation with y equaling 0, I like the purple, I didn't know where that came from. So I've got 1/2 times the absolute value of negative 2/3 x minus 4, and then go minus 3 at the end. I need to add 3 to both sides, so I'm going to have 3 equals 1/2 times the absolute value of negative 2/3 x minus 4. Multiply both sides by 2, I get 6 equals the absolute value of negative 2/3 x minus 4. Now you may recall that at this particular point, what this means is with an absolute value that I have to break it apart. And so I'm going to break it apart. I'm going to solve it two separate ways. I'm going to write negative 2/3 x minus 4 equals 6, or negative 2/3 x. Let me get rid of this x equals negative 6 right down here. I'll write a little higher so I have room. Wow. Let's see. Let me try it again. That's x equals negative 6 right there. Or negative 2/3 x minus 4 equals the opposite of that, or negative 6. Excuse me for the cough. So I'm going to go ahead and solve both of these. The one on the left, I will add 4 to both sides. So it gives me negative 2/3 x equals 10. Multiply both sides by negative 3/2. And I get x equals negative 30 over 2, which is x equals negative 15. Hey, that's the one x-intercept that was off my graph. So I can put that one in right now. So I have both x-intercepts. Negative 15 comma 0 was the other one. Now let's continue on down and let's show the other solution so you can see how it should come out as x equals 3. But let's just make sure. If I add 4 to both sides, I get negative 2/3 x. Add 4 to negative 6, you get negative 2. Multiply by negative 3/2 here. And on both sides, and I get x equals 6 over 2, or x equals 3, which is exactly what I was expecting. So my x-intercept is 3 comma 0, my or negative 15 comma 0, so there's got to be 2 of them there. And my y-intercept is just going to be, we found from the graph, is going to be 0 comma negative 1. But if we needed to, don't forget you also always could have just set in 0 for x, and then solve for y, and you would have ended up getting y equals negative 1. Now, as far as your domain is concerned in this case, once again, the domain, that's probably like the easiest one to deal with. The domain is going to be all real numbers because that x values will go all the way to negative infinity to positive infinity. And the range, so this time starts at negative 3, but this time it goes up. So I'm going to put y is greater than or equal to negative 3. So I now have my range, I have my domain, I've got my y-intercept, I have my two x-intercepts, I have my axis symmetry, which is x equals negative 6, and I have my vertex point at negative 6, negative 3, and I have my graph. And I didn't plot any points. Like I didn't go put together a chart and plot like 4 or 5 points, and I knew exactly where my v was going to be. And that's the beauty of solving it this way. Thank you, and have a wonderful rest of your day.